In this question, we're told that f of x is continuous, and we're given the graph of the derivative below. And so in this graph, we see 4 different intervals. We have an interval from negative infinity all the way to negative 3. Then we have from negative 3 to positive 1. Then we have from positive 1 to positive 3. And then we have from positive 3 to infinity. So, and it is telling us to consider the following statements. Statement 1 is telling us that f of x has a local maximum at x equals 1. Statement 2 says f of x has a local minimum at x equals negative 3. And statement 3 is telling you that f of x has neither a local minimum or maximum at x equals 3. And your job is to figure out if each of these are true or false. And the way we can do this is by using an interval chart or a number line, because we're given the derivative already. So we can go ahead and use the first derivative test. And that way we can see when the derivative is positive or negative, and that will correspond to the original function f of x increasing or decreasing for those intervals. So in this graph, we see from negative 3 and then until negative infinity, it is above the x-axis. And so that means that the derivative is positive here. So we can say positive. And then from negative 3 all the way to 1, it is below the x-axis. And so we can say that it is negative for that interval. Likewise, between 1 and positive 3, it is below the x-axis, and so we're also going to say that the derivative is negative for that interval. And then all of a sudden, from 3 onwards, we see that it is above the x-axis, and therefore we say that the derivative f prime of x is positive for that interval. So now we can make our interval chart. So we can plot our intervals now. So negative infinity, negative 3, 1, 3, and then infinity. So between negative infinity and negative 3, we said that f prime of x is positive. And between negative 3 and 1, it was negative. Between 1 and 3, it was also negative, and between 3 to infinity, it is positive. And so what can we say about f of x from all of this information? Well, if the derivative was positive between negative infinity to negative 3, that means that the original function must have been increasing for that interval. Now, from negative 3 to 1, it was negative. So that means that the original function must have been decreasing for that interval. Likewise, from 1 to 3, it is also negative, so it still stays decreasing. And then from 3 to positive infinity, the derivative is positive, and that means for that interval, f of x must be increasing. And from this, we can now answer the following questions. So statement 1 says that f of x has a local maximum at x equals 1. We see right here that at x equals 1, the intervals of decrease does not change at all. It stays negative for both of these intervals, and so the original function stays decreasing for both of them. It is not changing the interval of decrease or increase, and therefore we do not have a maximum nor a minimum at that point. And so therefore we can say that this statement is false. Statement 2 says that f of x has a local minimum at x equals negative 3. X equals negative 3 is right over here, and we see that we go from increasing to decreasing. And so if we're going to go from increasing to decreasing, we're going to have a point right here. And if we have a point at the top right here, that means that is a maximum and it is not a minimum. Therefore, this statement is also false. And to correct this, we would have to say there is a local maximum at x equals negative 3. And then for statement 3, it says that f of x has neither a local minimum or maximum at x equals 3. So x equals 3 is right over here. And this statement is claiming there's neither of them there. However, we see that from 1 to 3 we are decreasing, and then from 3 to infinity we are increasing. And so if that's the case, we should have a point right here. And if the point is at the bottom, that means that is a minimum. And because of that, we can go ahead and say that this statement is also false.